Question 42 reads, a construction worker accidentally drops a brick from a high scaffold. A. What is the velocity of the brick after 4 seconds? First, we list our given information. We're only looking at A right now, so we definitely have 4 seconds, which is the time. But don't forget, anytime something is dropped, there is more given information. On Earth, the acceleration due to gravity is 9.8 meters per second squared. This fact is usually left out on word problems, but it's something you should remember. Your unknown variable is the velocity, as stated in the problem up here. So what we're looking for is an equation with time, acceleration due to gravity, and speed. The closest equation is Vf equals V naught plus At, and if you read the problem, you can probably figure out right away that the V naught, the initial speed, is 0. This is very common in word problems. Construction worker accidentally drops a brick from a high scaffold. Unless they actually say the initial speed, you can go ahead and assume it's 0. So the two things that trip people up in freefall problems is the word problem doesn't actually state the acceleration due to gravity. They assume that you know that because it's falling. And unless otherwise stated, you can usually assume the initial speed or the final speed if it hits the ground is 0. Now you'll notice in the equation I have AT. So what is the acceleration? Remember, G does not stand for gravity. G stands for the acceleration due to gravity. So G is our acceleration. So we'll be sure to plug in 9.8 meters per second squared for the acceleration. Now remember, our initial speed is 0, so V naught will actually cancel out to 0 and we can ignore that. And we can simply plug in 9.8 meters per second squared times 4 seconds, our time. One of the seconds on the bottom cancels, seconds on the top, and we're left with meters per second, which is the correct unit for velocity or speed. And if you multiply this out, it comes out to 39.2 meters per second. So that's how fast the brick is falling after 4 seconds. Now part 2, letter B says, how far does the brick fall during this time? So how far means distance, and we've got the same amount of time. We have acceleration due to gravity, so we still know a lot of information from before. We can go ahead and add the final speed from before. It may or may not be important, but we can at least write it down. And like we said, we're trying to find out how far it fell. The closest equation is distance equals V naught t plus 1/2 gt squared. And again, the initial speed, V naught, is equal to 0, so we can cancel that out, and we get d equals 1/2 gt squared. At this point, I would hope that you remember that acceleration is g, since we're talking about free fall, so I'm just plugging in g now, instead of a. Now notice my time, 4 seconds squared, that squared applies to the 4 and the seconds, so it will allow me to cancel out the units seconds. Make sure that you apply that 2 to the 4, otherwise we get the wrong number. And when we plug it all in the calculator, we get a distance of 78.4 meters. That's all there is to it.